it already happened.
Right now, something the size of a continent just slammed into Jupiter at 200,000 kilometers per hour. We don't know what it was. We may never know. Jupiter swallowed it whole and didn't even notice. Not a planet, a machine. 4.5 billion years old, still running and still hungry. And here's what should genuinely disturb you. Jupiter is the reason you exist, and it's the reason you could stop existing. Both. I'll explain. 1,300 Earths could fit inside Jupiter. Its mass is 2.5 times greater than every other planet combined. So try this. Imagine you're standing on Jupiter's cloud tops. You look left, nothing but atmosphere for 143,000 kilometers. You look right, same. You look down, and there is no ground. There has never been a ground. The gas just gets thicker and heavier and hotter until it stops being gas at all. And you are the size of a virus on a basketball. Jupiter isn't big. Jupiter is a different category of existence. Here's the detail that changes everything. Jupiter almost wasn't a planet. If it had been 80 times more massive during formation, nuclear fusion would have ignited in its core. We'd have two suns. Earth likely wouldn't exist. Life on this planet is a direct consequence of Jupiter failing to become a star. Think about that. You are here because Jupiter fell short. Now look closer at the surface. Except there is no surface. What you're seeing is atmosphere. Thousands of kilometers of it, stacked in bands, churning against each other at speeds that make Earth's hurricanes look like a ceiling fan. The Great Red Spot. You've seen pictures. Maybe you learned about it in school. What you probably weren't told, it's been raging continuously for at least 400 years, possibly much longer. We don't know when it started because it was already there when we first pointed telescopes at Jupiter in the 1600s. That storm is older than modern science, and it is larger than Earth. Wind speeds at its edge, 400 kilometers per hour. That's a Category 5 hurricane, at the calm outer edge. The jet streams deeper in the atmosphere, over 600 kilometers per hour, faster than the speed of sound on Earth. And here's what the Juno mission revealed that we did not expect. These storms are not surface phenomena. They go down, hundreds of kilometers into the planet. The bands you see from space are the tops of weather systems that penetrate deep into Jupiter's interior. We don't fully understand how that's possible. We just know it's there. The deeper you go into Jupiter, the pressure builds. At a certain depth, and this is real, this is physics, the pressure becomes so extreme that hydrogen stops being a gas. It becomes liquid. And then it becomes something that has no parallel on Earth. Liquid metallic hydrogen. A state of matter where electrons are ripped away from their atoms and flow freely, like electricity through a wire. Except the wire is an ocean of hydrogen thousands of kilometers thick. This is where Jupiter's magnetic field comes from. Remember the failed star? A star generates its magnetic field the same way, through conducting plasma in its core. Jupiter does the same thing. It never became a star, but it kept the engine. Now here's where this stops being interesting and starts being terrifying. Earth's magnetic field protects us. It deflects the solar wind, traps charged particles, makes the planet livable. Jupiter's magnetic field is 20,000 times stronger than Earth's. It doesn't protect, it accelerates. Jupiter takes charged particles from the solar wind and whips them up to nearly the speed of light. These particles form radiation belts surrounding the planet, and those belts are not a barrier you can survive. If you were exposed, unprotected, at the distance of Jupiter's closest moon, you'd be dead in under 10 minutes. Not from heat, not from pressure. From radiation systematically destroying your DNA faster than your cells can repair it. NASA's Juno spacecraft, one of the most radiation-hardened machines ever built, carries a 200-kilogram titanium vault just to protect its electronics. and it can only make close passes for a few hours at a time before the radiation threatens to shut it down. The Galileo probe, which plunged into Jupiter's atmosphere in 1995, received a radiation dose equivalent to 25 million dental X-rays before it was crushed and vaporized. We sent a machine in. The machine didn't survive. Jupiter's gravity is not background. It is active, and it has fundamentally shaped the solar system's architecture for 4.5 billion years. The Grand Tack hypothesis, one of the leading models of solar system formation, suggests Jupiter migrated inward, close to where Mars is now, before being pulled back out by Saturn. During that migration, it scattered debris. It absorbed protoplanets. It prevented Mars from ever reaching its full size. It's why the asteroid belt is rubble instead of a planet. Jupiter wouldn't let one form. And it's still shaping it now. Comets, asteroids, rogue objects drifting in from the outer solar system. Jupiter is constantly intercepting them, pulling them into its gravity, flinging them into the sun, or redirecting them somewhere else entirely. In 1994, we watched this in real time. Comet Shoemaker-Levy 9 was captured by Jupiter's gravity and torn into 21 fragments. Then, over 6 days, each fragment slammed into Jupiter's atmosphere at 60 kilometers per second. The impacts left scars visible from Earth, larger than Earth. The energy released was equivalent to hundreds of millions of nuclear warheads. If that comet had reached the inner solar system instead, if Jupiter hadn't been there, the trajectory models suggest it could have hit Earth. Extinction-level event. Gone. Jupiter saved us. This time. But the same gravity that deflects threats also creates them. Scientists debate whether Jupiter is a shield or a catapult, whether it protects the inner solar system or seeds it with danger. The honest answer is both, simultaneously, always. Jupiter has 95 known moons, and they are not refuges, they are prisoners. Io, the closest large moon, is the most volcanically active body in the entire solar system. Not because of internal heat like Earth, because Jupiter is squeezing it. Tidal forces from Jupiter's gravity flex Io's interior constantly, generating enough heat to keep its entire surface in a state of eruption. Io's surface reshapes itself every few years. There are volcanic plumes shooting material 500 kilometers into space. It is a world being physically destroyed by its own orbit. Europa has a subsurface ocean, liquid water, possibly more than all of Earth's oceans combined. This is the place scientists consider the most likely candidate for extraterrestrial life in our solar system. But Europa orbits inside Jupiter's radiation belts. The surface receives 5,400 millisieverts of radiation per day. The annual lethal dose for a human is around 4,000 millisieverts total. Any life that exists in Europa's ocean is protected only because it's under kilometers of ice. Any spacecraft we send there will have its electronics fried within days of landing on the surface. And Ganymede, the largest moon in the solar system, larger than Mercury, has its own magnetic field, the only moon anywhere that does. But even that isn't enough. Jupiter's field overwhelms it, compresses it, dominates it. These are not worlds in Jupiter's neighborhood. They are worlds in Jupiter's grip. So why do we keep sending spacecraft there? Because the things that make Jupiter terrifying are the same things that make it irreplaceable as a laboratory. The liquid metallic hydrogen interior. We can't create that on Earth. Studying it tells us how gas giants form, which helps us understand the thousands of similar planets we found orbiting other stars, which helps us understand whether life elsewhere is common or rare. The moons, Europa especially, represent our best near-term shot at answering the question that has defined human curiosity since we first looked up. Are we alone? Juno has been orbiting Jupiter since 2016. The data it's returned has already rewritten our models. The core isn't solid, it's diffuse, fuzzy, still absorbing. The atmospheric dynamics go far deeper than expected. The The auroras, powered by Io's volcanic output feeding material along magnetic field lines, produce light shows that dwarf anything on Earth. Every answer Jupiter gives raises 5 more questions, and those questions point outward, toward every other solar system in the galaxy. Jupiter has been there for 4.5 billion years, before the first microbe, before the first fish, before us. Violent, indifferent, and central to everything, the whole time. When you see it in the night sky, that steady, bright point, you're not looking at a peaceful neighbor. You're looking at the thing that decided what the solar system would become. The reason the asteroid belt is rubble. The reason Mars is small. The reason Earth is here. The reason that comet didn't reach us. Jupiter isn't the king of the planets because it's the biggest. It's the king because it's been running the solar system the entire time, and nothing has ever come close to challenging it.